Okay, so welcome back to Objective 2 of 4.8, using the quadratic formula and this thing called the discriminant. Objective 2 is all about the discriminant. So take a look at this picture. Teacher there looks a little bit angry. I have no idea why. Pointing at some expressions, and those expressions might look a little bit familiar. That b squared minus 4ac business, that is called the discriminant. And we're going to use that thing to be able to tell how many solutions and what kind of solutions we have to any quadratic equation. So, in order to make sense of this, let's answer these questions. So based on the previous exercises, we've used the quadratic formula quite a bit now. How can the quadratic formula tell you how many solutions to expect? There's the first one. Second one, how can the quadratic formula tell you what kind of solutions to expect? Like, are they going to be real or imaginary? Are they going to be rational or irrational? And then finally, number 3, how are the roots related to each other if they are indeed irrational or imaginary? So let's take this one at a time. So the first one, how can that quadratic formula tell us how many answers to expect? So let's go back in time just a little bit. Back here on this exercise 2, we had 3 of them to test our knowledge out of the quadratic formula. Here was the first one. Answer to it was 3 plus or minus the square root of 5. Notice there are 2 answers there, 3 plus the square root of 5 and 3 minus the square root of 5. On the second one, all I get was the fraction 3 over 2. The reason why I only got one answer is because of that square root of 0 that was right there. I'm adding and subtracting nothing, so I only have one answer. Okay, that's the key. This last one here, 5 plus or minus I square root 115 divided by 10. I have 2 answers there. So as you can see, the number of solutions is going to depend on whether or not I have something underneath that square root. If I have either a negative number, like this one, negative 115, I'm going to have 2 answers. And if I have a positive number like this one, like square root of 20, then I'm going to have 2 answers. How do I only have one answer? Well, that's whenever I have just 0 underneath that radicand. So let's write this up. Quadratic formula can help you tell how many solutions to expect by just looking at this expression, b squared minus 4ac. That's the stuff that's underneath that square root. If it is positive or if it's negative, we know we're going to have 2 answers. So positive or negative gives us 2 answers. 2 answers. Now, what did we say? What's got to be true about it? If it's going to give us only one answer, then that means that b squared minus 4ac is equal to 0. It's not positive, it's not negative, it's just equal to 0. This means that we're going to have one answer. Alright so far? Okay. So now, how can the quadratic formula tell us what kind of answers to expect, whether they're real or imaginary, rational or irrational? Again, this is all dependent upon that square root. So, what kind of answers do I have here? 3 plus or minus the square root of 5. They are both real and they are irrational. Irrational because I've got a square root of 5 and that's not a perfect square. Okay, on this one, I only have one answer, and it is a real number and it's a rational number. Reason why it's a rational number is because it's got a square root of 0, and I take that away, there's no square root anymore. Also, if this square root was a perfect square, that square root would disappear, and I'd be left with some more rational numbers. But again, they'd be real. This last one, the square root of a negative 115, it's imaginary because I'm taking the square root of a negative number. Alright, so writing this thing up, again, it's dependent upon this b squared minus 4ac. How do I know if I'm going to have real or imaginary numbers? If this thing is greater than or equal to 0, this means I'm going to have real answers. Right? Correct. Now, if it is less than 0, b squared minus 4ac is less than 0, this means I'm going to have imaginary answers. How about rational or irrational? Okay, if, well, this is only on, here, let me get rid of this line. I don't know why I did that. It's only on the real ones, because only real ones are real or are irrational or irrational. Those are the two flavors. So I'm going to get rational ones if that determinant is either 0 or perfect square. I guess I could say perfect square that is greater than or equal to 0. Okay. And I know that I'm going to have irrational ones if it's an imperfect square. An imperfect square that's greater than 0. I'm not going to say greater than or equal to 0, because if it was equal to 0, then they'd be rational again. Alright, last part of this one. How are the roots related to each other if they are irrational or imaginary? You've done enough of these to know probably already what this answer is. So on this one, I've got 3 plus the square root of 5 and 3 minus the square root of 5. What kind of answers are those? This one, meh. How about that one? 5 plus or minus I square root 115 over 10. Do you know what kind of answers these are? Of course you do. Those things are conjugates. So the answer on this one, how are these things related? If they are irrational or imaginary, just simply they are conjugates. So to summarize all that, for the discriminant, quadratic formula, that expression, b squared minus 4ac is called a discriminant. It's called a discriminant because it's discriminating between what kinds and how many answers we're going to have. If b squared minus 4ac is greater than 0, we're going to have 2 real solutions. If I look at the graph of that thing, that parabola is going to touch the x-axis at 2 different places. Those are our 2 x-intercepts. Okay, if b squared minus 4ac is equal to 0, it's right there in the middle, we're going to only have 1 real solution, because that square root is going to disappear, and then I just am left with some sort of fraction. And if I look at the parabola, I have 1 x-intercept. That's where that vertex is going to touch the x-axis. Okay, last case is if that b squared minus 4ac is less than 0. If it's negative, that means I'm taking the square root of a negative number. I'm going to have 2 imaginary solutions. If I look at that parabola, it's not going to touch the x-axis at all. It's going to be up above that x-axis or perhaps down below it. So let's apply that in this next exercise. So find the discriminant of this quadratic equation. Give the number and type of solutions of each of these equations. So we don't have to solve it. All we have to do is use the quadratic formula. No, we use the discriminant of the quadratic formula. That's that b squared minus 4ac. Okay, so my b is 10. 10 squared is 100. Minus 4 times a, which is 1, times c, which is 23. See, 4 times 23, that's 80, plus 12 is 92. So we get 9. It's a positive number. This means that I'm going to have 2 real answers. Easy enough, right? Okay, next one. Notice that the equation is almost exactly the same, except now I have 25 for my c. So b squared is 100 minus 4 times 1, again, this time times 25. 4 times 25 is 100. So now 100 minus 100 equals 0. This means the square root is going to disappear, and I only have 1 real answer. Alright, perhaps by process of elimination you already know what the answer is going to be on the next one. Let's go ahead and work it out just because. So, again I have 100 minus 4 times 1 times my c is 27 this time. See, 4 times 20 is 80, plus 28, 108. This time I get a negative 8, which is less than 0, which means I'm going to have 2 imaginary answers. Alright. Easy enough, right? Well, you think it's easy enough until you see this last problem. So this is definitely a challenge problem. Find the value of k such that equation has 2 real solutions, 1 real solution, and 2 imaginary solutions. Well, all of that sounds like I'm going to apply the discriminant, and that's correct. If you look at the equation, I've got some sort of variable in it. Well, why don't I just apply the good old discriminant to this? The b squared minus 4ac on it. What's my b? My b is equal to, well, this is weird, negative 2k. It's the whole thing right in front of that. What's my a? My a is equal to, it's understood 1. And then finally, my c is equal to k. Alright, why don't you go ahead and give that a try. I'm going to tend to rowing real quick. Come back and see me, see if you can figure this out.